Hello all, welcome back to operating system course. So in the last video we had seen about operating system structure and operations, and in the operations we had seen dual mode and timer. Okay, so in this video we will start about process management, how a process is managed by your operating system. Okay, now first we have to understand what is a program. Okay, a program is a collection of instructions written into a language that your operating system understands. Now, what is a process? A process is a program that is being executed. Okay, your program, whenever it is executing, it is called as a process. Now, a process it needs certain amount of resources to complete its task. Now, these resources are your CPU time, memory, files, and IO devices. Okay. Now, the operating system allocates these resources to the process whenever the process is created or it is being executed. Okay. Now we will understand how operating system is responsible in connection with the process management. What are the activities that will be done by your operating system in process management? Okay. The first one is scheduling processes and threads on the CPUs. Now we know what is a process. Okay. So process is nothing but your program which is executing. Now your operating system is in charge of selecting the process that has to be executed. Which process it has to select, then what are the resources that has to be allocated. So your operating system is in charge of this activity. Along with that, it is also concerned with the threads. Now, what is a thread? Okay, a thread is a unit of execution within a process. Okay, your process will contain thread. A process can have one thread or many threads. So, whenever process starts, it is assigned some resources, right? Now, each thread within the process it shares the memory and the resources. Understand? So the first activity of the operating system is to schedule or to select the process for execution and managing of the threads. Okay. The second one is creating and deleting both user and system processes. As we all know, the operating system is assigned to allocate the resources needed by the process. The resources can be your CPU, time, memory, files, IO devices, etc. Okay. Now, so these needed resources, it will be allocated to a process by the operating system. And whenever those are not required by the process, these have to be taken back or it has to be freed. Now, this activity will also be done by your operating system. Okay. Next one is suspending and resuming processes. Okay, your operating system it will govern what process must be run first based on the priorities and some based on the strategies. So what if there are two or more processes queuing to run, right? Now your operating system will prioritize the process that has the highest priority. And say suppose some medium priority process is running, so your operating system what it will do, it will suspend that process and it will give or it will execute the highest priority process. So whenever that execution is completed, your operating system will come back to this process which has been suspended, and then it will start resuming that particular process or it starts executing that medium process. Okay. The next one, providing mechanism for process synchronization. So operating system will manage the way multiple processes are executed simultaneously. The goal is here to avoid the inconsistency of data due to accessing of the same data, also to set the order of process so that each process can run smoothly. Okay. The last one is providing mechanisms for process communication. Again, the OS, it provides a mechanism for multiple processes to interact and communicate. And how this will be done? For example, it can be done by sharing of the resources between process. So the multiple process, when they interact and communicate with each other, so how it will, your operating system works here is without causing any disruption to the processes which are sharing the resources. Okay, apart from this five, there is one more activity, that is providing mechanism for handling deadlock. Okay, now what is deadlock and all, we will see in the coming chapters. Okay, the next one is memory management. Main memory is the central place of operation for the modern computer system, right? So main memory, it is a large array of words, or it is bytes. So each word or the byte has its own address, remember. And whenever a process needs certain resources, right, for execution, like CPU time, memory, files, IO devices, so that its task can be done. So whenever you want to execute a program, it has to be brought from the job pool to the main memory, and its execution has to be then started. Now we will see how operating system plays an important role, or what are the activities of the operating system in connection with the memory management. So the first one is keeping track of which parts of the memory are currently being used or by whom. For example, if we consider, okay, if we consider this as our main memory, and you have OS over here, and then say your job 1, or basically the program 1, program 2, or job 2, something like this, right? So your operating system is now responsible of keeping track of, say, which process or which program is in which place or in which memory location. Okay, and the next one is deciding which processes and data to move into and out of the memory. Say suppose this process, or this program job 1 or else, okay, so it needs some of the IO devices, or it needs some data. So when that has to be brought into the memory, when it has to go out of the memory. So even this activity is monitored by your operating system. Then the last one is allocating and deallocating memory space as needed. So for example, here we have job 1 and job 2, right? Say suppose execution of this job 1 is done. That means the process will terminate there, right? Then once that process has been terminated, this memory space would be free, right? Then your operating system will decide from the job pool which job has to be selected, or which program has to be selected, and it has to be brought into the memory. Now these three are the activities of your operating system in connection with the memory management. So the next one is storage management. To make your computer system convenient for the users, the operating system provides a uniform or logical view of the information storage. The operating system, it abstracts from the physical properties of its storage devices to define a logical unit, that is the file. Okay, the operating system then maps these files onto physical media and accesses these files via storage devices. So how your operating system will come into picture, or what is the responsibility of operating system in connection with the storage? So that may be file system storage, mass storage, and caching. Okay, so we will see these things one by one. So in storage management, the first one is file system management. Okay, so what is a file then? A file is a collection of related information defined by its creator. So this file management is one of the most visible components of any operating system. Your computers can store information on several different types of physical media in magnetic disk, optical disk, magnetic tapes, etc. So each of these media has its own characteristics and physical organization. Each medium is controlled by a device such as your tape drive, disk drive, and it has also its own unique characteristics, right? Now, these properties include the access speed, capacity, data transfer rate, and the access method, whether it's sequential access or random access. So first in that we'll see the file, right? We have seen the definition of file. So commonly the files represent programs, that is your source and object programs, and in object forms and data. So data files may be, it can be a numeric file, alphabetic file, alphanumeric file, and or binary files, right? Okay, so the files may be free form, for example your text files, or they can be formatted rigidly, for example fixed fields. So the operating system, it implements the abstract concept of the file by managing mass storage media such as the tapes and disk and the devices that control them. Okay, now we will see how operating system, or what are the responsibilities or activities of the operating system in management of this file. So your operating system is responsible for creating and deleting files, where it has to be created, in which place, and once its use is done, how it has to be deleted and where it has to go. Next, creating and deleting directories to organize the files in directories or folders in order to allow their efficient storage and retrieval. So this is particularly so in the case of your computers where the user needs to navigate to one or more specific files to access them. So without this compartmentalization, or the directories or the folders, it would, even if it is not impossible task, but it would prove inconvenient task. So as like your files deletion, so unnecessary directories or the folders, they have to be removed in order to keep the system uncluttered. Okay. So the third one is supporting primitives for manipulating files and directories. Manipulating files means you can either copy it, move it, rename, delete, something like this. Okay. Since the operating system allow application software to perform the file manipulation using symbolic instructions, your operating system itself needs to have a machine level instruction set in order to interface with the hardware directly. The operating system contains provisions to manage the machine level file manipulation. For this, you have commands such as open, flush, etc. Okay. The next one, mapping files onto secondary storage. The operating system need to be able to map the files and folders to their physical location on the permanent storage in order to able to in order to able to be store and retrieve them. So this will be recorded in some form of disk directory, which varies according to the file systems or the systems that the operating system uses. The operating system will include a mechanism to locate the separate file segments where it has divided a file. The last one is backing up files. So your computer's storage, permanent storage devices, they generally contain a number of mechanical devices which can fail, and the storage media itself can be, it may be degraded. So a function of operating system is to remove the risk of data loss by backing up the files on additional secure and stable media in a redundant system. So these five are the activities of your operating system in connection with the file management. The next one is mass storage management. As because your main memory, it is too small to accommodate all the data and programs, and because the data that it holds are lost whenever the power is lost, the computer system must provide a secondary storage to back up your main memory. So the proper management of disk storage, it is the central importance of a or to a computer system. So your operating system is responsible for which of the activities in connection with the disk management or mass storage management. So those are free space management, then storage allocation, and the third one is disk scheduling. As because the secondary storage is used frequently, it must be used efficiently. The entire speed of the operation of a computer may hinder or hinge on the speed of your disk subsystem and of the algorithms that manipulate that particular subsystem. So the first one, free space management. It means the system it keeps track of the free disk blocks for allocating space to the files when they are created. So to reuse the space released from deleting the files, the free space management it becomes crucial. So your operating system is responsible for managing this particular activity, like in disk which block is free. Okay. Next one is storage allocation. So here your operating system it decides how your computer programs are assigned memory or space. The last one is disk scheduling. So this disk scheduling it is a technique used by the operating system to schedule multiple requests for accessing the disk. So we have multiple algorithms for disk scheduling. So we'll see that in the next chapter. So the next one is caching. Caching is an important principle of the computer systems. So information is normally kept in some storage system such as your main memory. As it is used, it is copied onto a faster storage system, the cache on a temporary basis. So when we need a particular piece of information, we first check whether it is present in the cache. So if it is present, we use this information directly from the cache. So if suppose we do not have that information in the cache, we use the information from the source. So putting a copy in that cache under the assumption that we will not need it again soon. So there are also caches that are implemented totally in hardware. For example, most systems have an instruction cache to hold the next instruction to be executed. So without this cache, the CPU would have to wait several clock cycles while the instruction is being fetched from the main memory. Again, your caches have limited size, so cache management is an important design problem. So this below diagram it shows the hierarchical storage structure, that is the data A it is present or it appears in different levels of storage system. So this A is an integer, okay, and say suppose its value has to be incremented by 1. Suppose think that this integer A it is present in a file B and that file is present in this magnetic disk. So to increment that value, first what we have to do is first we have to issue, that is operating system has to issue an IO operation to copy the disk block on which A resides to the main memory. Okay, now this operation it is followed by a copying this integer A to cache memory. Okay, and from the cache memory to the hardware register or internal register, that is the copy of A now appears at several places, that is in your magnetic disk, main memory, cache and internal register. Okay, the next one is IO systems. One of the purpose of the operating system is to hide the feature of specific hardware devices from the user. So for example, in Unix, the features of the IO devices are hidden from the bulk of the operating system itself by the IO subsystem. The IO subsystem, it consists of several components. The first one is the memory management component that includes buffering, then caching and spooling. So buffering means to store the data temporarily in the buffer. Spooling means to put the data into a temporary working area so it can be accessed and processed by another program or resource. The next component is general device driver interface, and the next one is drivers for specific hardware devices. So in the storage management, so we had seen about file system management, activities of operating system in connection with the file management. Then we had seen mass storage management or the disk management and its activities in connection with operating systems activities in connection with the disk management. The third one we had seen about caching, and the last one was IO systems. That's it for today. We'll conclude our session. Thank you.